Plant breeding, efficiency and effectiveness. Introduction. When choosing which plants to crossbreed, I want to help farmers all across the world make more well-informed choices. Problem. Due to complex genetics, not all plants produced by crossbreeding turn out as desired. This might have an unfavorable impact on the growth of these plants. The most crucial aspect of this is that it is challenging to choose which crops should be planted where and how they should interact in order to generate a hybridized and perfect version of your plant. Farmers would be the target audience for this project. Summary of research. I did a thorough research on genetically modified and hybridized plants as well as the procedures involved in their production. I discovered that growing two plants adjacent to one another will allow them to naturally cross-pollinate by having their seeds fertilized by insects and wind. As a result, the new hybrid plant may have genes from both parent plants. I also discovered that every plant has a variety of genes, some of which farmers find desirable, such as greater resilience, growth, and yield, and negative ones like higher water usage and lack of unique genes. It's crucial to grow just specific plants that will provide the desired results since plants contain both good and bad genes. Project plan. Criteria and constraints. The project must meet the following criteria. Its information must be accurate and its code must work. It must flawlessly and properly convey my concept. Some limitations include its informal nature due to the fact that I lack the ability to adequately reflect my ideas on platforms such as apps or websites. My calculator is fairly simple and was created on a coding platform called Replit. Materials and design of prototype. I created and tested my program with Replit and conducted research on my area of interest, plant genetics, using the internet and different websites. My program begins with an overview and description of how my project works. The calculator then requests user input, including the user's preferred gene type for their plant and the gene code of the 5 plants they have available for crossbreeding. From then, this calculator provides the 3 best plants that the farmer may crossbreed to get their desired result using for loops, arrays, if statements, and other functions of Java. Test and evaluate. Testing your prototype. I did not test my entire program at once, but rather in several pieces. I started by checking my print statements to make sure they were accurate and making sure I had the right imports. After testing my for loops and if statements, I fixed any mistakes. I completed my code with the necessary finishing touches and ran it through many inputs to check for faults. I utilized tracing, a technique to ensure that my code was free of errors. In computer programming, tracing is the process of predicting the outcome of your code given a certain input and comparing your findings to those of the computer. If they line up, the code is right. If not, it has to be corrected. Data and results. Hi, welcome to the Plant Crossbreeding Calculator. This tool can help inform you on what plants to crossbreed to get a certain result. This calculator works only with 5 gene codes at a time. Happy planting! Gene reference, Y is equal to yield, G equals growth, H equals resistance to weather, W equals high water consumption, X equals no special gene. Your desired gene code of 5 plants that you have. Crossbreed these plants to get your desired one. Conclusions. Analysis of data and redesign. All of my active code is included in this data. Initially, I had planned to start utilizing 2D arrays. After conducting some testing, I decided that switching to ordinary arrays would be the best course of action. As indicated in my commented code, I also made the decision to convert each user input into an array. However, after testing, I saw that there were some mistakes with the associated indexes, so I revised my code again. Additionally, I created a function that would determine which gene code most closely matched the desired gene code, and I eventually discovered how to output 3 of the most closely matching gene codes so the farmer could utilize them all rather than just one. All of these mistakes aided in my progress toward the final design of my prototype. Conclusion. The initial goal was to simplify plant breeding for farmers worldwide by developing a calculator that allowed farmers to create their perfect plant by entering the genes they want in their new plant and the existing genes in their current plants. They would then receive a response from the calculator indicating which 3 plants crossbreed the easiest. There are several ways to create hybrid plants, one of which is by a natural process in which 2 plants that are planted together might result in a crossbred variety of the plant. This calculator seeks to reach the precise result that can only be obtained by using selected plants. This project may be developed further using more complex gene codes with intricate coding, as it is only a prototype and I am a beginner coder. Thank you for watching my presentation.